YouTube channel. Today we will do the next method, that is variation of parameter to find particular integral. So first of all, this method is always used to find particular integral, and especially this is used to find particular integral of second order differential equation. If we have second order differential equation, on in that case we are able to find particular integral by using variation of parameter method. So here, first of all, what is the equation of the type? Equation of the type is y dash plus py dash, sorry, y double dash plus py dash plus qy equal to x. As we can see that it is a second order differential equation, and second thing is that it is a non-homogeneous differential equation. So we will know that if we have non-homogeneous differential equation, only in that case we are able to find particular integral. Okay, then here what is a p and q? P and q is again a constant, and x, what is x? X is the function of small x. So its particular integral can be given in this way. Here we can see that what is the value of x. X is given to you. Now we have to find what is y1 and what is y2. So always remember y1 and y2 is a solution of this differential equation. As we know that y1 and y2 is solution of homogeneous differential equation. Whenever we have y double dash plus py dash plus qy equal to 0, you will find here the values. We will always find two values, y1 and y2. That is known as your solution of homogeneous differential equation, or we can say that it is a complementary function also. So after this, what is the w? W is known as Wronski's. Its value can be given by determinant of y1, y2 and y1 dash, y2 dash. Now let's start with the equation so that we will get a better idea of that. The equation is del square y by del x square, then plus y equal to secant x. First of all, what we will do, we will write it down this equation into the symbolic form. How can you write down this equation into symbolic form? It can be replaced by d plus 1. Y is taken as a common. It is a secant x, because we know that d is just an operator, like here it's a operator. After doing this, first of all, we will write it down its auxiliary equation. As we know what is auxiliary equation, whenever the coefficient of y is equal to 0, that is known as auxiliary equation. By doing this auxiliary equation, we will find the complementary function of this equation. So auxiliary equation is d square plus 1 is equal to 0. We will solve it by d square, that is minus 1. So d is equal to plus minus root minus 1. So it can be plus minus iota. As we easily know, if we have value, if we have a root, that is alpha plus minus iota beta, in that case, what is the solution? Solution is given by complementary function, or solution is given by, it is e raised to by alpha x c1 cos beta x plus c2 sin beta x. Now we can easily compare these two equations. In this case, we alpha is equals to 0 and our beta is equal to 1. So how can we write it down? Complementary function of y, we will write it down e raised to power alpha. Alpha is 0x. It is c1 cos beta x, means it is cos x plus c2 sin x. So again it is 1. You will get with c1 cos x plus c2 sin x. So we can easily remember, we can easily identify that in this case here we have two values, cos and sine. So from this we will take y1 is cos x and we will take y2 is sine x. We are not taking constant by finding a particular integral. So here we can also find the value of x. What is x? X is secant x, so we can write it down the value of secant x also. Now if we will go over method, it says that we have already find the value of y1, we have find the value of y2, we know what is the x. Now we have to just work for w. So what is the w? W says that w can be taken as, that is y1, y2, y1 dash and y2 dash. So we will easily write it down. It is a cos x, it is a sin x, and derivative of cos x is again known as minus of sin x, and derivative of sin x is taken as cos x. After that we have to take a determinant. Determinant is, here it is multiplied by cos square x minus, it's again minus sin square x. So cos square x plus sin square x can be taken here as 1. So as what is the particular integral? Particular integral for y can be taken as minus, it can be taken as minus y1, sorry, it can be taken as minus y1 integration of y2 into x divided by w dx plus y2 integration of y1 x into divided by w into dx. Now we know that y1 is minus cos x, integration of sin x, x is here secant x, divided by 1 dx plus y2 is again sin x, integration of, again here is a cos x, secant x divided by 1 dx. Now we have to just solve this integration. It is minus cos x integration of sin x into secant x dx plus sin x integration of cos x into secant x dx. So we know that what is the value of secant x? Secant x can be taken as 1 by cos x. So it is minus cos x integration of sin x into 1 by cos x dx plus sin x into cos x into 1 by cos x dx. So sin x divided by cos x, it can be changed into integration of tan x dx, and here we will left only with 1 integration of 1 dx. We know that what is the integration of tan x? Tan x can be taken as negative of log mod of cos x, then plus sin x, integration of 1x can be taken as x only. So if we will simplify, it is cos x log of cos x plus sin x. This is the value for a particular integral definitely. Now we know that what is a complete solution. Complete solution of y can be taken as complementary function plus particular integral. So as we can see, what is our complementary function? It is c1 cos x plus c2 sin x. So we will write down that y is equals to c1 cos x plus c2 sin x. Similarly, what is the value for a particular integral? It can be cos log mod of cos x plus sin x. Sorry, here is x is also multiplied. So x is here. So in this case, cos log of mod of cos x. So it is cos x log of mod of cos x plus x into sin. So this is a solution of our differential equation. Thank you so much. In our next video, we will go with the question based on the same topic. Thank you very much.